Hello, welcome back. Today, we're going to talk about, as it says, the transformation of functions. What we mean by transformation is basically taking a function, like basic functions you may have seen before, like a parabola or a square root function, something like that, and basically altering it in some way, stretching, compressing it, shifting it left and right. Those are called transformations. And we'll take a look at those today. So our goals, as it says, be able to perform these transformations of shifting, stretching, compressing, and reflecting. We'll define those. Be able to combine these transformations for a single function in the correct order. So we'll see how once we've learned the transformations, we can actually then combine, have more than one transformation. We also want to make sure that we do those the same order. It's a bit like order of operations for transformations. So make sure we all do the same thing and we all understand the order we're doing. So make sure we all are doing the same thing at the same time. Now, let's take a look at our first shift. And let's come over here. So our first transformation is going to be a vertical shift. Okay, we're going to start the function. I'm just going to simply call f of x. It's going to be a made-up function. It's not going to be a known function. We're going to come down here and draw this. So we're going to connect 3 points, 0, 0, 2, 4, and negative 2 and 4. Right, so this is going to be our function. This is going to be our f of x. Now, let's take a look over here. Then on the left, see what a vertical shift is. And it's basically what it sounds like. It says in a vertical shift, we move the graph up and down. So we don't change the shape. We're simply taking the graph and moving it. Imagine if we drag it and move it up and down. That's what we're doing. It says the shape of the graph doesn't change. And the x-coordinate also of our points doesn't change, only the y-coordinates. It says for a function f of x and some constant we're going to call k. Then if we add k to it, for f of x, it means we're going to shift the graph up that many units, whatever k is. When we subtract it, it means we're going to shift it down that many units. And it says also we're going to add plus or minus k to the y-coordinate. So let's look at our first example there. So this is our basic function. Now, let me also choose a different color. And in red, let's do y equals f of x plus 2. Okay, so what this is going to do is going to shift f of x up 2 units. Okay, so that's just what it sounds like. So what it says, once again, so we're going to, for our coordinate, for our points, the x coordinate is not going to change, but the y coordinate will change. We're going to shift each y coordinate up 2 units. So point 0, 0 will now go to 0, 2. The point 2, 4 will now go to 2, 6. And the point negative 2, 4 will go to negative 2, 6. And so that is our new graph. So this is 0, 2. This is 2, 6. And this is negative 2, 6. Okay, so once again, we just taken the graph and just shifted it up. We haven't changed the shape. And in shifting it upward, we just added 2 to our y-coordinates, and our x-coordinates have stayed the same. Now, let's change colors once again. Let's do a downward shift. Let's choose this blue or purple color. Then, as you might expect, we're going to do y equals f of x minus 2. And this is going to shift our original graph, f of x, down 2 units. So let's do that. And so here, this point is going to go from 0, 0 is going to 0, negative 2. This point here, that was at 2, 4 is going to go down to 2, 2. And over here, the one that was at negative 2, 4 is going to go to negative 2 and 2. And so this function will look like this. So once again, what we've done is taken original graph f of x and shifted it down 2 units. And once again, what that does for our coordinates, our points on the graph, the x coordinate stays the same, but the y coordinate is subtracted by 2, and so it moves that coordinate down, so move the entire graph down 2 without changing its shape. So that's what a vertical shift looks like. Now, let's go down. And let's do that again for a horizontal shift. We'll explain what it is, and then we'll do some examples. In the same way. So let's come back over here to the left, and this will explain what a horizontal shift is. All right, so once again, I'm going to start with my same graph, these same points, 0, 0, 2, 4, and negative 2, 4. Once again, this is giving me my f of x. Should be a straight line. And so horizontal shift, in much the same way a vertical shift, what a vertical shift does, a horizontal shift essentially takes the graph and moves it to the left or right. Okay, so I'll just read this. In a horizontal shift, move the graph left or right. The shape of the graph doesn't change, once again, like a vertical shift. And the y-coordinate doesn't change, but the x-coordinate changes. For function f of x, we add some constant we're going to call h. And here is where it's the opposite of what you'd expect. If we have a plus on the inside, plus h, actually that's a shift to the left, x units. Okay, but if it's minus h, that's a shift to the right, h units. Okay, so we're going to add plus or minus h to the x coordinate. As we'll see, it's actually going to shift it in the opposite direction we expect, but by that amount. And once again, here, our y coordinates won't change, but our x coordinate will change. So, the same way, we're going to start out with our y equals f of x in black. Now, let's shift to the right. So let's make this red, and let's say let's do y equals f. I'm going to shift to the right. Let's do x minus 2. Okay, so what this is going to do is going to shift original graph f of x right 2 units. Let's do that. Once again, what that will do for our coordinates, for our points on the graph, we'll essentially add 2 to each one of our x coordinates. So point 0, 0 will now be at 2, 0. The point 2, 4 will now be 2, 6. Or sorry, it would be 4, 4 rather. I'm sorry. Be at 4, 4. So just adding 2 to the x coordinate. And this point here is that negative 2, 4 will now be at 0, 4. So once again, if we connect our dots for this graph, once again, the shape has not changed. And our y coordinates have not changed. The only thing that's changed are our x coordinates. So that's a shift to the right. And once again, it's a minus 2 on the inside. It's opposite what you'd expect. Now, like we did before, let's also do another shift in the opposite direction. Let's go back to a blue. This time, we'll do y equals f of x plus 2. And that's going to be a shift. We're going to shift f of x left 2 units. Okay, so once again, we're going to subtract 2 from each one of our x coordinates and leave the y coordinates as they are. So the point 0, 0 will now go to negative 2, 0. The point that was at 2, 4 is going to go to 0, 4. It's actually in the same spot as this one. Now the point -2, 4 is going to go right here. And that's actually going to be -4, 4. So we connect those dots. That gives us our new function. Once again, our shape is not changed. We just dragged it to the left. So a +2 on the inside means you drag it to the left 2 units. Exactly the same shape. And once again, we just subtracted 2 from our x-coordinates. Our y-coordinates were unchanged. And that's a horizontal shift. Now, let's take a look at the next idea. So far, we haven't done anything to actually change the shape of our graph. We will for our next one. So for our next one, we're going to do, as it says, vertical compression and stretching. So let's read this. So it says vertical compression or stretching does change the shape of the graph, as we mentioned. In vertical stretching or compressing, the x-coordinate doesn't change, but the y-coordinate changes. So that's kind of a trend you'll see. Anything we do vertically only changes our y-coordinates. So it says for a function f of x and a constant a. So we have a multiplied on the outside of f of x. This is a vertical compression if our a is between 0 and 1. Okay. Then that same a, if it's bigger than 1, is a vertical stretching. Essentially, so what we're doing is essentially making our y-coordinate either smaller if it's between 0 and 1, that's compression, or larger if it's greater than 1. It says you multiply the y-coordinate of our point by a, whatever a is. Let's take a look at that. So once again, we're going to start out with our y equals f of x, the same graph. And these techniques work for any graph. So this is 0, 0, or 0.2, 4. And our point -2, 4. So once again, here is our original graph. Now, let's get our first example. So once again, we're going to do this also by 2. So first, we're going to write y is equal to 2 times f of x. But since f of x is y, you can imagine 2 times that makes y twice as big. Okay. What this is going to be a vertical stretching. This is going to stretch. Oops. Sorry, I forgot to do that in a different color. So give me a moment. Let me change that to, so I'll make that red. So y equals 2 times f of x. And let's get what this is going to be. This is going to be a vertical or stretch vertically. Stretch f of x vertically. I'll just abbreviate that by 2. Okay. Now, once again, what the effect that's have is our x coordinates won't change. We're going to multiply our y coordinates by, in this case, our a, which is 2. So if you notice here, once again, the x coordinate stays where it is. The y coordinate, multiply that by 2, but 2 times 0 is still 0. So we still have one point of our graph here. Then this point, so the x coordinate stays at 2. We multiply the y coordinate by 2, though, and it goes to 8. It goes to 2, 8. And then over here, the same thing happens. X coordinate stays at -2, then the y coordinate multiplied by 2, that also becomes 8. So this point here then is -2 and 8. And so this is our stretched graph. Once again, I'm trying to draw a straight line. So imagine just taking the graph and pulling it, stretching it up by a factor of 2. That's what we're doing. That's a vertical stretching. Now, let's do a vertical compression. So this time we need a number between 0 and 1. So I want to do it by a factor of 2. Then it's going to let me change colors. And we'll do y is equal to, by a factor of 2, it needs to be 1/2 f of x. Okay, and this is going to be, we're going to compress f of x once again vertically by 2. And basically what it means is we're going to multiply the y-coordinate of our function, the y-coordinate of each point, by a, in this case 1/2. So we're going to divide each one of our y-coordinates by 2, and once again our x-coordinate will stay where it is. Now, once again for 0, 0, 0 divided by 2 is still 0. So this point still stays in the same spot for this graph as well. This is also still 0, 0. But, so once again for this point, 2, 4, still 2 for x, and then 4 is divided by 2. That's going to give us 2, 2. And likewise over here, the y-coordinate will become 2, so this point will be -2 and 2. So if we graph this, this is our compressed graph. Okay, so imagine if we take this original graph of y-coordinate and just compress it down by a factor of 2, that's what that looks like, a vertical compression. So once again, vertical compression does change the shape of the graph, and basically this only, as far as the coordinates, only affects your y-coordinates. Now, as you would probably expect, we can also compress or stretch horizontally. So let's take a look at that. We're talking about horizontal compression. I'll also abbreviate that, and stretching. I'll also abbreviate both those. So horizontal compression and stretching. Let's go and just start with our same graph, our same y equals f of x. So I will graph that down here in this new graph. And we'll see what happens to this. So let's come over here to the left and read this. It says horizontal compression or stretching can change the shape of the graph. The y-coordinate doesn't change, but the x-coordinate changes. So for a function f of x and some constant we're going to call b. Now b this time is multiplied inside the parentheses times the x itself. And this one, once again, is kind of opposite what you might expect. So if b is between 0 and 1, then actually that's a horizontal stretching. You might think it'd be compression, it's actually a stretching. And then if b is greater than 1, that's actually a horizontal compression. So let's see the effect of both of those in the same way. So let me go back to our red color. So this time, let's do y equals f of 2x. This time, this number right in front of the x is bigger than 1. This should be a horizontal compression. Okay, so what this is going to do is going to compress f of x horizontally, abbreviate that, by 2. We're going to press it by 2. Let's take a look at each one of our points. So then what we're going to do then is that you multiply the x-coordinate of fx by actually 1 over that, which is a tiny bit more difficult. But multiply the y-coordinate, so the x-coordinate, by 1/2. So now 0.00. Once again, our y-coordinates won't change on any of our points, but the x-coordinate will change unless, in this case, 1/2 times 0 is still 0. So we still have this point right here. So for some graphs, 0, 0 will be kind of like an anchor point for shifting pressing, because it's not going to go anywhere if the 0, 0 is on the graph. Now, what about 0.24? So this says we multiply the x-coordinate by 1 over b, or 1 over 2. So essentially it's going to be 1/2 times this, which is going to be x-coordinate, which is going to be 1. So then the y-coordinate will still be at 4. So this is going to be now at 1, 4. Similarly over here, we'll multiply the x-coordinate by 1/2. And so that's going to be -1 and 4. So now this is our graph. See, it's compressed horizontally. So we take it and push it together, kind of like an accordion. All right. Essentially is now half the width. So that is horizontal compressing. Okay. Then, once again, of course, let's do an example of horizontal stretching. So if we just make this number 1/2 now. So y equals f of 1/2 x. And so that, based on what we said, should be we're going to stretch f of x horizontally. Once again, by a factor of 2. Let's take a look at that. So this time, this one's also, I have to think about this just a bit. It says you multiply the x coordinate by 1 over b. In this case, our b is 1/2. So 1 over 1/2, or the reciprocal of 1/2 is 2. So we're going to multiply each one of our x coordinates of the original graph by 2. Once again, 0, 0. 0 by 1/2, be 0 by 2 is still 0. So this point is still going to stay where it is. Oops, I realized I forgot to go back to the red just a minute. I realized I forgot to write that in there. That point is still there for 0, 0. Then we go back to the blue. So for each one of these compressions or stretches, either vertically or horizontally, if you have a point that's at 0, 0, it will stay where it is. Now, it says what's going to happen is that we're going to take each one of our x coordinates and multiply it by 2. So this point 2, 4 is now going to go to 4, 4. And similarly, this point that was at -2, 4, multiply the x coordinate by 2 is going to be -4, 4, which is actually going to be right here. That was kind of in the way, but you can see it. And now if we connect those points, this is our vertical or horizontally stretched graph, stretched by a factor of 2. Okay, so once again, so kind of review just a bit the basics in these basic transformations. Shifting, vertical or horizontal shifting, never changes the shape, but horizontal or vertical compression or stretching do change the shape. Now, we have 2 more types of basic transformations to discuss. And those are what are called reflections. Let's take a look at each one of those. So we have a vertical reflection about the x-axis and reflection about the y-axis. So first off, let's take a look at reflection about the x-axis. This is basically a vertical reflection. Let's see what this means. So let me read it. It says y equals negative f of x, so a negative out front of fx is a reflection of f of x about the x-axis. The shape of the graph doesn't change in a reflection. And the x-coordinate doesn't change. Once again, only since we're doing about, this is vertical, about the x-axis, the sign of the y-coordinate changes. Multiply the y-coordinate by 1. So let's go back to our basic graph again, our same y equals f of x. And graph it again. Now, let's do a reflection about the x-axis. So I'll go to red here. I'm going to graph y is equal to negative f of x. Once again, what this is a reflection about the x-axis, or a vertical reflection. So imagine if I could take, this graph, imagine I could just turn, I could turn, there's a screw on this side and actually turn the axis. I could just flip this over, give me a mirror image of this graph across the x-axis. That's what I would get. So once again, what does my coordinate points? It says, once again, I don't change, this is vertical, I don't change the x coordinates, I only change the y coordinates. Multiply the y coordinate by 1. And once again, in this case, 0, 0. Since the y -1 times 0 is 0, the y coordinate stays where it is. Now, each one of these, once again, the x coordinate doesn't change. The y coordinate changes signs. This point goes to 2, -4. And likewise, this point here goes, oops, it was at -2, 4 goes to -2, -4. And so this is the reflection through the x-axis, or the vertical reflection of this graph. Shape stays the same as the original, but just a reflection or a mirror image of this graph across the x-axis. And then our last transformation. And we're going to do the same thing. We have also a horizontal reflection, a reflection about the y-axis. And this is a horizontal reflection. Okay, so once again, let's read this over here on the left. As it says, if we put the negative inside the parentheses, y equals f of negative x is a reflection of f of x about the y-axis. The shape of the graph, once again, doesn't change for reflection. And the y-coordinate doesn't change for horizontal reflection about the y-axis. The sign of the x-coordinate does change. Multiply the x-coordinate by -1. So it's going to start with our basic graph again, y equals f of x, the same one we've been using. So 0, 0, 2, 4, and then -2, 4. Now, let's see what happens. So now we're going to graph. This time, I think I'll use the blue color for this one. Y equals negative, or sorry, not there. Y equals f of negative x. Once again, what this is a reflection about the y-axis. Okay, so we take the graph and basically put a mirror image of this graph across the y-axis. Okay, it says what I'm going to do is I'm not going to change my y-coordinates. I will multiply my x-coordinates by a -1, basically change the signs of my x-coordinates. Once again, 0, 0, x is 0, so -0 is still 0. This still stays exactly where it is. Actually, give me a moment. I realize I probably forgot to do something up here. Yes, excuse me. I just realized I forgot to do something. I should have put a 0, 0 there. Good. Now let's go back down to this one. Okay. Now the point 2, 4. Okay. It's actually going to, so I'm going to, the y coordinate will stay the same. Multiply the x coordinate by 2. That's going to be -2, which is, of course, already on our graph. So this point is going to swap. It's going to move over here. -2, 4. And then, as you might expect, the same thing's going to happen here. Multiply this x coordinate by a -1, change its sign, it will become 2, 4. So, interesting thing happens. And for this particular graph, this doesn't happen very often. But for this particular graph, I get the same Sorry, that erased both of them. Give me a moment. I didn't need to erase both of them, so let's draw that again. The original, and then probably won't be able to draw the blue line exactly over the black line, so we have to imagine that they're exactly the same. Now, this happens for this particular graph. That's because this graph is what's called symmetric about the y-axis. That's why this happens. This won't happen in most graphs. But once again, it's a mirror image about the y-axis. So I could, once again, if there was a screw, I could turn the y-axis around. Then you see I get exactly the same graph. So that's the reflection. So to review quickly, we can have horizontal or vertical shifts. They don't change the shape. Horizontal or vertical compression or stretching do change the shape. And reflections also do not change the shape. Now, we can also have combinations of graphs, and we'll talk about that. Give me just a moment. I probably need to add, may need to add a few more pages here. Oops, what did I just, sorry, I didn't mean to do that. I accidentally stopped sharing my screen. But I'm still recording, so that's good. I need to add so to make sure I have enough, more than enough pages that I need to finish everything. There. Shouldn't need that many. I want to make sure I have enough. So let's go back. Now, let's talk about the next idea, which involves combinations. So now that we've learned the basic transformations, now we can actually combine them and have combinations of transformations. Okay, so let's come back over here to the left and talk about this. So for a function y equals f of x, we can combine any of the transformations above to create something that looks like this. So just remember what everything here does. The k, that's our vertical shift up or down. H is our horizontal shift left to right. The b, that affects our horizontal compressing or stretching. And finally, the a out front affects our vertical compressing or stretching. Now, in order to make sure that we do everything consistently, and everyone else in the world does everything consistently with this, we need to follow basically like an order of operations. And that's what this is. So the first thing you do, if you see a graph, you see an equation for a function, want to graph it, the first thing you do to graph it, you do the horizontal shift, then a horizontal stretch compression if it has that, then reflection about the y-axis, vertical stretch or compression, then reflection about the x-axis, and then finally a vertical shift. So we use that order then to make sure we're all doing the same thing. So now, let's take a look at an example. And the example we're going to do is going to be this. First one anyway, y equals x plus 1 minus 2. So now let's identify what we're actually doing here and also try to make sure I understand the order. So what we're looking at then, remember what this does, this -2 out front, that's a vertical shift. And then this 1 on the inside, that's like the k. And the 1 on the inside works as the h, that's a horizontal shift. Okay, so now in the order, what we're going to do then is what this says. So this is going to be a horizontal shift. Now, which way and how much? So remember, this one is opposite what you'd think on the inside. If it's plus, it means we're going to shift to the left. So it's horizontal shift left 1 unit. And then the other factor then is if there's a vertical shift, and remember this is the sign is what you'd think, negative, so it's down. It's going to be a vertical shift down 1 unit. Okay, so let's take a look at that. So also we're starting out for a base graph. Um, let me write this over here. So our f of x is our ordinary graph, just the absolute value of x. Okay, so let's draw that first, and then we'll go from there. Okay, so if we remember the absolute value, if you see that before, that starts off at, there's a point at 0, 0, for example. Then let's pick, I would pick a 5. So goes to 5, 5. That's another point on that graph. Because if x is 5, y is 5. And then negative 5, 5. So if x is negative 5, that becomes 5. And of course, it looks kind of like this. And it should go through those points. So this is our y equals f of x. So this is y equals the absolute value of x. Now, some can help to actually do these in stages and parts to make sure we do it right. Okay. So what I'm going to do is let's first do this horizontal shift to the left. What's going to change colors. I'm going intermediate color. Also do a dotted line so we can see the difference. So here, this is a horizontal shift left 1 unit. So I'm going to take this graph and shift left 1 unit. So remember what that's going to do is it's not going to change my y coordinates. My x coordinates will actually change by 1, negative 1. So it's going to go to negative 1, 0. Here, this one's going to go to negative 6, 5. This one will go to 4, 5. Now, I'm going to make this a dotted line because this is not my final graph. This is essentially like an intermediate. Okay, so this red graph is y equals the absolute value of x plus 1. What this helps us to do then, now we just have to do one more thing. Okay, we need to now take the red graph and shift it down 2. That will give us our final graph. Let's do that. So once again, from the red graph, you know a vertical shift doesn't change our x coordinates, but it changes our y coordinates. We're going to move, subtract 2 from all our y coordinates. At this point, negative 1, 0 will go down to negative 1, negative 2. This point at 4, 5 will go to down to go down to 3, 5. I'm sorry, yeah, we'll go to vertical shift, so we go to 4, 3 rather. Because the x coordinate stays the same, but the y coordinate will be reduced by 2. This one likewise will go from negative 6, 5 to negative 6, 3. Sorry, I should have also changed my color here. I apologize. Let me do that again. So I actually need to erase a few things. Erase that and this. So let me start this over. Okay. So this one will go to negative 1, negative 2. This point will go to 4, 3. And this point will go to negative 6, 3. Now, so this, if I connect those dots, and trying to connect them, a little hard to write on this writing pad, but that will be the graph of y equals x plus 1 minus 2. Actually, let me see if I can draw this just a bit better. So there we go. Okay. And so once again, we start with the original graph. We shifted it to the right, we started to the left, 1, and then down 2 and got our final graph, the blue line. Okay. Let's do one more example of that. This time, let's do this example. This time we're going to do y is equal to the square root of 2 minus x. Now, one thing, let's actually rewrite that. It might help write it this way first, as negative x plus 2. Just put it more in the form of this. Okay. Now, let's see what we have. And once again, what we want to do. So remember what this number here. So inside, essentially, this is like inside the parentheses in a sense. And also our starting with, this is the transformation of y equals the square root of x. So that basic graph. Now, so let's start from there. So what we're doing is, so the 2 plus 2, that's going to be a horizontal shift. And then the minus here in front of the x, then actually that will be a reflection across the y-axis. Okay, and here, one thing I mentioned, these a or b, if they're negative, those are reflections. So, and if we do those in order, you have the horizontal shift before you do the reflection about the x-axis. So, what we do first is this is a horizontal shift. And which way is it going? Once again, it's plus. It's opposite what you think. It's going to be going to the left 2 units. Okay. And then the next one, then, we have this negative, which is a reflection. Well, it's also a horizontal shift of this, f of x, a reflection. Through or about the y-axis. I should say here also. Make sure it's clear of f of x. Okay, our basic, I can write that as f of x, our base graph, which is this. Okay, f of x, which is that. So of f of x. And let me make sure I did that above here as well to be consistent. Okay, now, so all this is also of f of x here in the previous one. So make sure that's clear what we're doing. Okay, so do a similar thing for this one. What we're going to do is first off, start with the graph of the square root function. And so let's do a couple points. So that point, the square root of 0 is 0. That point also goes to 0, 0. And then do another point. Let's do 4, 2. Just do a couple points. We'll get the idea. So 4, 2. So this graph looks like this. Okay, it's kind of a parabolic kind of shape, kind of a flat parabola going in this direction, half of one. Okay, so this is our f of x. Or I'll write it as, well, y equals the square root of x. Okay, now, once again, what we do first is this horizontal shift to the left. So once again, what that's going to do, that's our shape is going to stay the same. And then it's only going to affect our x coordinates. So we're going to subtract 2 from all our x coordinates. So let's do that. Let's go do an intermediate graph for that. So let's go, I'm going to do that in red. So the first part. So this point 0, 0 is going to go to negative 2, 0. And this point 4, 2 is going to go to 2, 2. Now, once again, I'm going to draw this as a dotted line. This is going to be an intermediate graph. This is not actually our final graph. This, then, is y equals the square root of x plus 2. Now, let's do our last part then. So now we want to do a reflection about the y-axis. And so what the reflection about the y-axis does is then that, what that does is that actually let's go back and take a look. shape of the graph doesn't change. The y-coordinate doesn't change, but the sign of the x-coordinate changes. Okay, so our x-coordinate changes, so we just change the sign of our x-coordinates. So once again, the y-coordinate doesn't change, so our intermediate point right here, negative 2, 0, is going to become, change the coordinate of that, that's going to be 2, 0. So that's going to go right here. So I need to put this in a new color, blue. So this point is now going to go to 2, 0. And our point right here, which is a 2, 2, is now going to go to negative 2, 2, since I multiplied the x-coordinate by negative 2. And then this then is going to look like this. So it should have exactly the same shape, even though I can't draw it perfectly well. And it's just a reflection, once again, through the y-axis of this graph. So if I can take this red graph and twist it through the y-axis, I would get this shape right here. So this is going to be y is equal to an original, which you can write either way. I'll just write it this way, so negative x plus 2. All right, so what we've seen so far today are, we've looked at each one of these changes, each one of these transformations. So our goals were to be able to form the transformations of shifting, stretching, compressing, and reflecting, we've done all those, and also combine the transformations into a single function in the correct order. So now let's do one more example. This time we're going to do a graph in which you're already given the graph, and we need to find out what transformation has taken place. Now, give me a moment. Let me draw this. So the point is we're going to draw a graph, and then we have to figure out what transformation has actually taken place. So let's go back to our black color. Let's say we have 2 points on our graph, negative 3, 0, and the point 0, negative 3. Now, this graph is going to look kind of like this. And actually, we're going to have one more point. It's going to be negative 6 and negative 3. So also, let's do 3 points. We're also going to have negative 6 and negative 3. Now, so the question, so this is our f of x. This is our y equals f of x. So we need to identify what it is. Okay, and figure out the transformation. So we're starting with a basic function. Figure out what transformations we took to get there. Okay, so looking at it, I think we probably guess what kind of a basic function it is. Essentially, it's a absolute value function. The basic function is absolute value function, or y equals the absolute value of x. Now, let's draw that in a different color to know what that graph should look like. So here I'll just use the red. I'm actually doing a couple intermediates here. So the absolute value function, as we've already drawn, looks like, or already seen, looks like this. So that's a point 0, 0. And then basically it's what's called the identity function. Well, it's to the left of 0, essentially the identity function. Okay. And on this side, then it's just the negative, or the identity function, essentially flipped up. Okay. So this is y equals the absolute value of x. Now, we want to figure out then is how it got from here to here, what transformations took place. Then we'll be able to write out then what this is. Okay, the equation for this. Now, let's take a look. So let's think about where our points go. Okay, let's think about this point 0, 0. Let's figure out where it went. Okay, so you kind of tell that basically this has been a shift of some kind from here to here. Okay, this has gone from 0, 0 to negative 3, 0. Okay, so once again, we see the point, change back to black here. Okay, so the point 0, 0 is gone to negative 3, 0. Okay, so that means that tells us it's going to be a horizontal shift of y equals f of x, or y equals the absolute value of x, right? Let's be more specific. Okay, 3 units left. Okay, so we can see that. Now, what else has happened? So you see, once you move it there, let's actually do that first. So here, once again, let me change colors to blue. Let's do an intermediate graph. So we're going to go to this point right here, which is negative 3, 0. So basically, if I draw this dotted line, it should look kind of like this. Okay, so this then is going to be that shift. Okay, and remember what that looks like then. Let's go back down here. Well, let's actually trying to figure out where I want to stay. Let's actually stay here. Now, if we shift that, we know the graph that will be is going to be y equals the absolute value of x plus 3. Okay, we've learned now we're shifting 3 units to the left. That's the same as a plus 3 on the inside. Okay, now, what last step do we need to do to get here? Okay, if we look at a couple points on this graph, we can start to see what's happening. Okay, so this point, if I drew it correctly, it should have gone at least through the point 0, 3. And this point should have gone through the point negative 6, 3. Okay. So the last thing that happened we can see is what's gone from here to here is actually then going to be a reflection, a vertical reflection through the x-axis. Okay. So I'll say down here, let's go back to black. I'll say then reflection through the x-axis, or a vertical reflection. Okay. And so what that does, if you remember then, that just multiplies, vertical reflection multiplies the function here out front by a negative. And so what this graph then is y equals negative absolute value of x plus 3. Okay, so the way to do that is basically figure out how you go from your basic graph to the final graph. Here, what transformations you do, make sure you think about the order we discussed, the order of those transformations, the combination as we did, like here, and be able to write that. Okay, so our graph is y equals negative absolute value of x plus 3. Okay, so that's our final example. So what we learned then is actually how to understand the basic transformations, how to graph them, what they all mean, then how to combine them, then also how to take a graph of function, be able to identify its equation by understanding those transformations. Thank you. Have a good day.